Appreciate it. So, hi everyone. Yeah, my name is Fadhil. I am adjunct faculty and lab coordinator and course coordinator at New York Institute of Technology here in New York City. I have completed my master's at the Bartlett School of Architecture a few years ago. And between teaching now and the Bartlett, I worked for Foster & Partners for about 4 years. You know, my interest in architecture is somewhere along the lines of, course, computational design and digital design and fabrication, but I'm very much also interested in sort of expanding beyond that and sort of including intelligence and you know, ecology and philosophy into that, into my work. And you know, the workshop that we will be doing today is definitely not driven by sort of systematic thinking, but it's more along the lines of you know, sort of discrete components and a design technique that is driven by sort of fabrication. And what I'm personally interested in my work is that how can we transfer or sort of move from the design of the components immediately into fabrication. And that's why I've always been working in a sort of small scale for the most part, you know, from product and maybe housing, very small scale, so that we can eliminate as much of the intermediate processes that sort of slow down architecture and also capitalize on almost translating the computational techniques into the physical reality almost immediately. And the way I'm doing that is using a software called Modo. It's by Foundry, and I'm just going to jump right into the software and show you some of the techniques I do, and you know, and how things sort of course, due to the constraints of time, I'm not going to be able to do sort of the physical aspect of things. Maybe that's a different workshop, but I'll show you the digital process of my sort of my workflow and how that sort of translates into the physical. So I'm going to go ahead and share my screen and start. Yeah.
Fadhil, questions? Do we ask questions as we go along, or we wait for?
Yeah, absolutely. Feel free to stop me whenever you feel like if I'm going too fast. And if there's any specifics about the design process or the techniques or the software itself, please absolutely ask me whenever. So I'm going to go ahead and share my screen. So I hope that you can see my screen. The software is open. Can you see it?
Yep.
Okay, excellent. And I'm just going to go ahead and real quickly save this. Okay, so that we don't lose. So this is Foundry software. It is it's a surface modeling software, very similar to a lot of the softwares out there, but I personally find it very helpful due to its sort of easy access and sort of intuitive organizational, you know, in terms of the tabs and the toolbars and how you access most of the commands. And just a quick introduction to Modo. It's a service modeling software, and just like a lot of the softwares that exist out there, you have the sort of the top banner that has all the sort of accessible, the file and the edits and the items and the windows up top. That's where you can sort of, those are the systematic commands that exist up top. And then the second banner is that when you move in between different modes within the software. So the software has a lot of different systems built within it, from sculpting to procedural design to surface modeling design. And I'm only showing surface modeling today, but of course I can get into the others in different workshops. Of course, animation and render, and there's also schematic fusion tab where you actually can script most of your work here. So that's sort of the top, and then the one below that is where you access the components of your design, and you'll see how I will do that as I go, and how you can apply sort of different ways onto the different, how you control different sort of points or polygons or edges of the meshes you're working with. And below that, you have, you know, where you change the screens and viewports and you know, different shading views, settings for your object. And the very end here, you have where you access your geometry, where you're starting with sort of the primitive geometry palettes. And on the side here, you have the different commands or the different sort of operations that you can apply to it in terms of the sculpting aspect of things. And as you go lower, you start seeing, different commands that control different parts of the geometry, whether it's vertices or edges or polygons. And then at the end, you have the fusion, which is a very similar sort of, it's the Boolean operation that we all know of in different softwares, but this one is more automated and sort of, it works in real time. And one more thing, on the right-hand side, you have, what's similar to layers and different meshes components. And below that, every time you have a mesh, you'll have different properties that you can control. And along that side, you have the meshes settings, you have the shading, which is the material palettes that you're working with. So what I would like to do is go ahead and start with a primitive geometry. And the goal for this workshop is to create a wall panel that, sort of ready to be prefabricated or fabricated right away, and has sort of different interactive elements within it and sort of integrated ecological systems pockets that are also that can be integrated. So I'm going to go ahead and I can start with a box. And the way you start on the box is you can click Control and you hit on the box, and it lands immediately at the center of it. I know that this is it's at the origin, so that's good. Before we go there, I mean, the commands that I will be using the most are the move, rotate, and scale. And you can control different parts of the geometry here. And of course, as I was saying, you have up top here different parts of the geometry that you can control: vertices, edges, and polygons. Or you can refer to your keyboards and you can use the numbers. Number 5 is typically that you control the primitive geometry itself. Number 4 is when you control the material. And then number 5 is where you control, number 3 is where you control the different polygons. And I'm just simply clicking on them. Number 2 is for the edges. This is, you're basically switching between the modes. So when you press number 2, you can never select the polygons themselves. And then number 1 is where you can control the vertices. Okay. And just a quick demonstration of how the sort of transform method works. If I start with, let's say we'll go with number 3, and then I wanted to move around or twist or rotate some of the polygons, then I simply go with number 3, click on the polygon I want, and you have W, E, and R on your keyboard are the commands for these transforms. So if W is the move, obviously you can use the gumball, and then you can control the distance through which you want to move these, the polygons or the edges that you're working with. You can, of course, move it up and down. If you're at the box, you can move it more freely. If you're interested in sort of snapping onto different elements, so you have the snapping command on, so you can snap on a different points on your coordinate system. But I typically have it off because my system is, or my way of design is a little bit more sort of less accurate, more along the sculpting sort of concept. So that's for the move. The same thing goes for rotate, which is E on your keyboard. And of course, you can use the handle to rotate in all different directions. What's interesting about this is that you can always reorient the transform tool perpendicular to your polygon. So if you press Alt S, the transform tool or gumball basically becomes perpendicular to your polygon, so that you're actually rotating it or moving it more accurately. And of course, you have R, which is the scale. You can scale in all directions, which is the center circle, or you can scale in different directions here. So I'm just taking some time here quickly just to introduce the different commands, and I'll get into actually designing a piece in a second. As I was saying earlier, you have all different kinds of primitive geometries you can start with. At the same time, you have for example, the vertices and the edges and the polygons, which are the tabs where you can access specific commands that are related to your to the edges or the vertices or the polygons. So for example, if I go to edges, which is number 2, immediately highlights edges here, then I go here, and all of these things are related to edges. So let's say, for example, if I wanted to add a loop to this, a loop is an edge that goes around the entire primitive geometry. So the loop, if I wanted to add a loop in the middle, as you can see, you can, it's added around the whole geometry, and then you can adjust the distance between the first loop, which is the top, or the bottom loop. So these are all related to edges. If I wanted to, let's say, go to polygons, then I have to be in number 3, or I can just simply click polygon. This way I can apply the commands that are in the polygons tab. And for example, if I wanted to extrude the space, then you simply go in and extrude another space beyond the polygon that you started with, and that immediately adds an edge in between. And of course, it takes out the polygon that was here. It doesn't leave a polygon in the center because that's a solid object. And so on and so forth with different commands that I will let people possibly, sort of play around with, because there are specific kinds of techniques that I wanted to introduce in a second. So I'm just going to go ahead and delete that. And actually, before I delete it, I just wanted to highlight a couple of things just to show you that, when you are in primitive object mode, where you can select the whole object, you can see that this is the mesh that you're working with. You have the camera, you have a direct light. Of course, your layers are automatically added as soon as you add a mesh, or you can always add a new mesh that's empty, which is basically the equivalent of a new layer by just pressing N on your keyboard. And that will give you a new set or a new layer for a new mesh. So for example, if I go to the Create tab and look at the different meshes, and let's move this one out of the way. We can go ahead and let's say I wanted to get sphere, and I want the sphere to go into this layer. It's mesh number 2, control, and double click on it, and that goes immediately here. What's really interesting is that once we access this layer, there's no way we can go into that object because it's a completely different layer. So if I go to the polygons or edges, I can only select edges and polygons and vertices of this object, but that will never happen in this object because it's not part of the layer. So that's just something to keep in mind if you want to work in different modes or different layers. And then, of course, as I was saying, if I press 5, just to be in the primitive geometry mode, then you can see that there are different properties that you can play around with. But for the sake of this, the only thing that I wanted to address is the sort of subdivision level, and 2 is typically what I work with. It's the equivalent of sort of tolerance, or sort of how curved do you want this geometry to be? How it's basically the resolution of it. And 1 is low res, 3 is specific for certain certain techniques or certain geometries that you want it to achieve, but 2 is typically good for most geometries that I work with. Another thing I wanted to highlight is the tab button, which actually turns the object from a subdivided mode to a boxy mode, because you can see now that regardless of the fact that this says sphere, you can see the edges of it clearly. It's a higher resolution sphere. That's why it looks like a sphere from far away, but when you zoom in, you can see the different polygons that are making that sphere, which means that this is sort of in the boxy mode. The entire Moda right now is in that mode. So if I double click on this to select all the polygons and hit tap, you see the difference in terms of it going into a subdivided mode which simply adds or curves the polygon and smooths them out to turn it into an actual sphere. It depends on your preference. Of course, if you're working in the boxy mode, the one thing you need to keep in mind is that if I wanted to increase the resolution of specific area, then I'm going to have to add more edges so that you have more polygons creating a certain surface. Or you can work within the subdivide mode so that all of your surfaces are high res and sort of optimized as you go along. For the sake of this workshop, I'm going to stick with a subdivided mode, and just so that I can go over the different techniques that I typically design with. And the techniques that I use are relatively straightforward and simple, but what I'm interested in is that the simple techniques that I will be introducing can easily sort of create high-level, complex objects that we can sort of take into fabrication almost immediately. And I will be thinking sort of about fabrication as I go, so that there aren't any problems with the designs once we transition into the fabrication aspect. So I'm just going to go ahead and delete these two because these were just sort of experimental, so that I can actually start with a new geometry. So what I'm going to do is I'm going to click on the box and start drawing it, because what I want here is to actually draw something to scale. So what I want, this is the X direction is 0 right now, which is fine. I'll increase it in a second. But what I want this to be is, let's say we set that to 2 meters. And then let's set this to 1 meter. Oh, that's the position of it. So now it's just going to move. Well, I guess we can set that to 0, 0 for now, just so that we can sit in the origin. And then when we talk about the size of it, we'll set that to 1 meter, and then you have 2. So now you have a wall panel, and then let's give it some thickness, possibly, let's say 200 mil. So now we have, let's say, a wall panel. Maybe that's a bit too thick, so I'll make it 100. Okay. One thing I want to switch is possibly make this 2, just so that it's vertical. Make this one 1. Now we have, let's say, a beginning of a wall panel. And what I call that is a primitive geometry that I'm starting with. What I'm going to go is probably just move it above so that it's not by 1 meter, so it's sitting right above the grid. So this is the sort of starting point here. And if you notice that if I double click on this, and I'm in the polygon mode right now because I can select polygon. If I press tab, that's going to turn into a sub D mode, and it takes away sort of all of it's no longer a box. It's kind of a spherical disc looking like thing, and this is not really what I wanted. So I'm just going to go back and add edges to the top of it, to the corners, so that when it actually turns into a sub D, there's an edge at every corner that holds it in place. And the way I do that, well, before I do that, let me just actually go ahead and save so that we don't lose our progress. And then, yeah, so what I'm going to do is go ahead and go to the edges and make sure that I'm in the edges sort of mode. And then I'm just going to go ahead and add edges to the top, to the side, and to the bottom. And as I'm doing this, I'm holding Shift so that I can add the edges, because sometimes it only adds one edge if you're not holding Shift. So now I know that all of these corners are bounded by the edges around it in every single side, which is good. And this way I'm going to be able to control and maintain sort of the size of the panel that I'm working with. So now when I go ahead and, let's say, hit tab, you see that my edges are in place. This is a sub D mode. box, you can see the difference between the two. And the edges are sort of now in between. What I'm also going to do is I'm going to add an edge in the middle of it. So basically, this is the first stage of me dealing with geometries. And the reason why I'm sort of introducing this, and this may not be sort of a BIM system or anything like that, this is sort of me trying to create architecture using sort of isolated components or objects that then we can turn into a physical sort of form rather than having to think about architecture as a rigid wall or a door or ceiling or roof. Because one component using this sort of modeling system can adapt and can, let's say, take different characteristics, whether it's it could be a semi-enclosed component that has sort of a floor quality and a wall quality, and then a roof also or ceiling component attached to it, and it's all within the same thing, and they all are connected using a specific sort of jointing system, which I will introduce in a second. So now that I have sort of the 2x1 wall panel, I've established the rules, and now what I'm going to do, what I would like to do is I want to create this 2x1 panel by dividing it in just right in the middle. And let's say I want to make it into 4 different pieces. And that's the way I wanted to fabricate it. And I'll show you in a second how to do that. And we'll use the edges to divide that wall. So I'm just going to go ahead and add a loop in the middle. And we can sort of adjust let's say we make that 50%, so that's right in the middle. And this way, these two distances, which is basically the distance from the next edge that's in the system, which is 614 and change mil. So that's good that I have something in the middle. I also want to add something in the middle that's vertical. So again, I'm going to go ahead and go to Add Edge and go parallel or perpendicular to the direction of the edge I want to add. So if I wanted to add an edge in the vertical direction, I'm going to have to go back or go into an edge that's perpendicular to it. Of course, if I wanted to add it the other direction, I'm going to have to go into an edge that's perpendicular to the direction of the edge I want to add. So I'm just going to go ahead and add one here. Of course, I'm going to go 50% because I want it to be right in the center. So that's good to go. Okay, so here's the wall or the panels I've created so far. And what I'm interested in now is that just so that I get a little bit more resolution, I'm going to add another edge in the middle of this and another edge in the middle, so that actually helps me start to sculpt the front and at least the front of and the back of this panel. And as you can see, every edge you add is a loop, so that rotates around the whole thing. I can potentially add an edge here just so that I can get rid of some of these strange sort of fillet. So I'm just going to go ahead and add a loop right in the middle, and that will give me a little bit more resolution. And again, I'll change that to 50, so that's right in the middle of that, in between the two edges. All right, so far I have the wall panel, and I'm just going to add 2 more edges, one in the middle here, and we'll do 50%, and another one in the middle here. You just press Shift and then click perpendicular to the direction you want to go to, and that will add another edge. And all right, so that's 50. That looks good to me. What I wanted to show is as well that there's another command, which is the slide, which is a way you can slide the edges. If you double click on an edge, that will take you around the whole loop, and then you can use the command slide to move it up and down. But in this case, for me, it's pretty much stationed wherever I want. It's exactly where I want it to be, so it's kind of there. I'm not going to move it, but you can definitely slide that edge using the slide to move it up and down. So that's the wall panel. Now what I'm going to do is I wanted to divide this in the middle, but I don't want it to be just straight shot of across. I wanted to have some kind of a nice curvature here, maybe something that can do a nice, so that two objects are interlocking in a sense, not necessarily just sort of joint in a way that is just simply vertical. So what I'm going to do is I'm going to go ahead and select pretty much all the edges here. And I'm just going to do treatment of the wall in the front of it. So I'm not going to do anything to the back of it for now. So now that I've selected all the edges, if you hit Shift, of course, you can add to your selection. And then you can use the rotate to rotate these edges. But now there's a little bit of a problem because I don't want it to go over the whole thing. You see that the surface is breaking, it's moving beyond the boundary, so this is not what I want. What I want is to have sort of distribute the force of the rotate, starting with the force being the strongest at the center, and have it to be at least, or at its sort of, at the weakest at the corners, so that it doesn't actually move my points or edges. So the way I'm going to do that, there's this thing called fall-offs here. And the fall-offs are different sort of, gradients or scopes that you can put around any object. And based on the shape or the characteristics of the fall-offs you're picking here, you can apply the forces. So I'm just going to go ahead and do cylindrical for now. And what this is giving me is that it's giving me a cylinder here, as you can see. It's purple, and you can see that this is already distributing the force vertically. So what I'm going to do is move this inward so that it doesn't move these edges. So there's going to be no force at this point. I'm just going to move this downward. So now you actually have the forces being applied in the center. So when you move this, the force is only going to happen at the center. So the way I'm going to do it is, I think this is okay for now. If I do it a little bit more. So that the wall is being sort of split right in the center of this. What I don't like about this is that this is kind of going beyond this point, so I'm just going to go ahead and take it down. And what's really interesting is this is kind of a parametric procedure. So as you move through, the applied forces of this fall off will change. So I want it to be just below the point, just beyond the point here. So now that's good. And then I'm just going to go ahead and give it a little bit of rotation. So that's really good. Now what I want to do is potentially move. So I'm just going to go ahead and keep the fall off here, and then go ahead and go with hit W, so I can go with the move tool, because I want this panel to not be flat, but I want it to kind of bulge out as it goes towards the center. So I'm just going to go ahead and hit move, and as you can see, W, which is right here, and you can see that the bulging is only happening at the center of this. Right? Then I can adjust how much I want to move it, and so I'm just going to go ahead and say I want to move it by negative 200 mil. Okay, so I think that's an okay for now. That's a good sculpted, well sculpted panel just in this direction. It's rather simple, but we'll add the complicated or more complex additional geometry to it in a second. So I'm just going to go ahead and exit out of everything. This is so far the wall that I have. I'm just going to go ahead and save so I don't lose my the work that I've established up to this point. Now what I want to do is I actually want to potentially move these two here so that the cut of the panel is not just along this edge, but also I want it to go along this edge, so probably we'll rotate it a little bit. I have the option to potentially lift this so that I have a little bit of rotation, maybe even lower this point. So again, you have a lot of control over everything. But the way I want to do this is also use another fall off. So I'm just going to go ahead and hit Control Z, and then we'll select these two. I will go ahead and do another fall off, which is radial. And I'm just going to go ahead and draw this radial fall off just around my edge. And what's nice about radial fall off is that it has a three-dimensional sort of characteristic to it. And then now that I have this fall off, I want it to be, of course, at the center to have the most force, and then at the edges to have the least force. So again, I'm going to go ahead and do rotate. And now when I, sorry, one second, let's just do that. Apply the fall off, radial, and go ahead and do the rotate in this direction. One second. Let's see what's going on. It looks like it's frozen. Let's use another one. Okay. Okay, now it's okay, that's good. Looks like it's rotating, but very slightly because the force is not really, it's just barely touching it. So now we're giving it a little bit more space so that the force is distributed a little bit more. You can see it moving, which is great. So that's good. And then let's say I'm going to move this up. I'm going to move the points here. Maybe move the point downwards. Okay. So now what's going to happen is that the cut of the wall will be somewhere in the middle. What I don't like here is that there's not enough resolution, so I probably would want to add a couple more edges here so I can adjust this curve. This doesn't look great, at least to me. So I'm just going to go ahead and add an edge here and there. So now I have a little bit more control over this. And I'm just going to go ahead and move this point up. So now we have light of a curve. Okay, that's slightly better. So basically all I'm doing is sort of sculpting this. As you can see, the back of the wall is not adjusted because I'm only doing the front of it. So now let's say we have this wall that has a bump in the middle, and then it's sort of going to be divided based on the center edges, based on this edge and this edge. And I think now I'm ready to sort of divide it and see how these things are going to react. So the first thing I'm going to save, I'm just afraid of it crashing in a minute. So I'm going to go ahead and start doing the division. No, this is the first round of adding sort of articulation to the panel itself. So the first thing I'm going to do is add a seam exactly where this edge is. So I'm just going to double click on it. And there's this, if I go to edges, and there's this bevel command here. And what the bevel is going to do is basically duplicate the edges, one above and one below, as you can see here. So now this is sort of duplicating the edge, giving me a little bit more resolution. And I can control that. We can make that 10 mil so that it's smaller, maybe even 5 mil. And we can control the distance of, yeah, that I was just adjusting. So I think that looks good to me. I think I want to cut it through here. I do like the fact that there is a little bit of a crease that's happening in the system. So that's the first thing. I'm adding a joint to this. And the way I'm going to do this, as it's selected, I'm going to go ahead and hit Alt-3. And what that does is basically switches me from edges mode to polygon mode. And what that does is that instead of having to choose the edges of the thing, or of the geometry that I was working with, that selects the polygons that are in between. So now that I have the polygons, I'm going to do the exact same operation, but through the polygon tab, and then we do bevel again. So now this is going to, again, duplicate the edges, give me one on each end. And all I'm going to do is push the edge inwards, and I'm going to go ahead and adjust the thickness of this thing so that it's just a seam. It's not necessarily anything it's relatively small. So, and push it inwards. So now this is adding it into this wall. All right, which is great. This is exactly what I wanted. Now we have a wall. It's sort of bulging and has a seam to it. And I'll go ahead and add another seam, which was the one that's right in the middle. The exact same thing here. But what I want to do is actually I don't want it to interact with the seam itself. So I'm just going to go ahead and go all the way to the. I don't want to add a seam within the seam itself. So I'm just going to go just outside of it. So there's a little bit of divide in between. I'm going to do the exact same operation. So I'm going to bevel the edge. Instead of having to go here and do bevel, I'm just going to hit B on the keyboard. That what B is for bevel. And what I'm going to do is add the exact same division. I'm going to duplicate the edges. I'm just going to need to make sure that things are not broken, which looks like they are. So what I'm going to do is I'll fix this later. Then I'm just going to go ahead and add the seam across the whole thing. So bevel, this looks better already. And it's not broken, which is great. And I'm just going to adjust it a little bit. I think we did 5 mil before that, so I'm just going to go ahead and do 5 mil. And then I'm going to hit B. I'm going to go ahead and, as I was saying, Alt-3 is to select the polygons that are in between. And then you hit bevel, and that's the opportunity for us to add another seam in between. And that, for me, is the joint system. So now I know for sure that there are 3 different ways I can do this. And actually, I even have the luxury to delete these polygons in between and really just bridge everything. But for now, I'll do it later. So that, I mean, the reason why I would delete these seams is so that I can have separate panels that are ready to be printed or CNC'd or whatever. So now I know that this wall is going to be made out of 4 different panels. And I have a seam in between. I know that these are going to sort of have this bulging effect. And the reason why I did do the bulge here is so that I wanted to implement some kind of, let's say, like a pocket or plant or something. And then I wanted to add another articulation at the bottom here to where we can incorporate a bench potentially, or you know, something else, so that it's actually a component that has all different kinds of sort of small components attached to it, not just a wall panel. So that's good. What I like here is that I guess what I don't like about the design so far is that it has kind of blobby edges here, and I wanted to control the edges, so potentially I can give it some thickness. You can add thickness to the edges so that you sharpen the design a little bit and give it a little bit more definition. So if I wanted to sharpen this edge, I would double click on it and hit Shift W. And then the Shift W will give it a little bit more definition. So you can see now it's kind of straight. And you can adjust that by adjusting the percentage of it here, of the weight. So if it's 50%, it's less. If it's 100%, that's the max. If it's 10%, so it's a little bit less definition. So I'm just going to go ahead and go 100 on this one. I'm also going to do double click on this, do the exact same thing. Shift W, which is to add the weight, and then adjust the thickness of it. I mean, I guess again, I was going to do 100, which is great. And that will give me a very sort of nice creased edge here. I guess I can do this on the other side. Here, which was 100%. And we'll do the same thing here. Shift W, 100%. And that sort of gives me a nice creased seam that goes around. And you know, the back of it is, for now, let's say this is the back of a panel, so it's fine. And here we are. I mean, I think up to this point, we've only made simple changes to this, and it's sort of ready to have further articulation. I do have this, in some cases, if you're working sort of in an evolutionary way where I am sort of starting from a simple geometry and then you move to the next one, you get to a point where you have some results that you would like to keep, so you don't want to save over it. You have the option to create another mesh and keep adding copies. Or if you want to save this and start fresh, as in, this, you can always go back to this version of your design. Then you can go file and then save incremental. And what's going to happen is that it's just going to save a new file that adds just a numeric sort of order to it. And now the file that you were working on previously, it was DC, just DC, and now it's DC0001. If I go incremental again, the file is going to be 002. So now you can go back wherever you saved your file and then sort of go backwards if you get to a point as you're sculpting, if you get to a point where you sort of want to take a step back and branch out into a different direction, or if you don't like your results, then you can go back to any of the increments that you've worked with and sort of go back and start from there. So far, I think I have I'm relatively satisfied with the design of this panel. I saved it. And what I want to do next is I want to make sure that essentially I want to add some articulation here. Maybe I can add a pocket of some sort that has, let's say a planting or some kind of a feature that can host something like seeds, or if you want to implement, if you're doing a bio panel of some sort and you want to implement something here, then you can. So I'm going to go ahead and add a couple of more edges here so I can control. So again, the edge, you can add it by going perpendicular to the direction through which you want to add the edge loop to. You press here, and you can see things are kind of changing, because that just means that the resolution of this is a little bit, it's increasing. So what I want to do in this case is I'm going to make sure that I have to adjust my design. And I'm just going to go ahead and select these and then sort of sculpt them and bring them back to where they were originally, so that I don't lose the resolution. Because every time you add an edge, you're adding more resolution, and sort of, kind of changes or shifts things a little bit. There's another way of doing this. So for example, if I'm satisfied with this and before I add an edge, and I know I'm going to add a lot of edges going forward, I'm going to increase the resolution of my geometry, you can hit D, and that will add edges everywhere, or basically double the amount of edges you have everywhere. Or if you have shift, if you do Shift D, what that's going to do is it's going to subdivide it in a way that has more force on the geometry itself. It doesn't preserve it. So what I typically do is, once I'm satisfied with this, select the whole thing and just press D, so that I can add more resolution to it. So that's good. I've added a little bit more resolution so that I know I'm going to be going in and adjusting some of the surface articulation in this geometry. But first thing is, I'm going to go ahead and, let's say I wanted to add something here that looks like an L shape, for example, and that has some kind of a, it's a bulge out that can host something inside. So I'm just going to go ahead and add. Before that, maybe I can start sculpting this a little bit. So I just want this to go up here. And sometimes we can, instead of having to do that, you can always go to vertices, and there's a slide, and that will help you slide your points a little bit so you can deform the, and that what's nice about that, it actually slides it along the edges, so that if there's something I want to add that has sort of an interesting shape. So instead of it being a straight line, I want it to be sort of, a curvature to it, or, let's say it curves downwards. then I can adjust that a little bit. Or I can actually manually move it. Just to make sure that this doesn't deform the geometry too much. So now that I have this, I want to move this a little bit too, just maybe up. I want to move this up a little bit. I'm just sort of into the trying to create the profile of the new component that I'm adding. And I know this component, I want it to be sort of, it kind of goes out and in, and it bulges out where this point is. So what I'm going to do is, again, select the edges here, cylinder. And what I'm going to do is I'm going to do it in the left view. And the way I switched is by, kind of going into your keyboard, and if you hit Control and Space, then you can change between the different views of your, or you can do that through here as well. You can do back, left, right, and all that stuff. So I was in the left, I think. And I want to make sure that whatever I'm drawing in terms of a fall off gets applied only here. So now I know this only happens here. And I'm going to go up a little bit and just make sure that the forces of my move is not distributed beyond these two things. And it's sort of parametric as it goes along. I'm going to move it. I'm just going to go here. Okay, let's try. Actually, there's something wrong with the fallout today, but let's try something else. I'm just going to go ahead and do this. I'm going to use a different command and see what's going on. Okay, that's a little bit better. I'm basically doing a linear fall off instead of the cylindrical, and trying to see what's going on. But that will do the exact same thing. So you know now that this is sort of distributing it along this curve or two edges that I am working with, and that sort of is giving me a little bit more space. What I want to do is things are getting a little bit floppy, so I can start sculpting it back again so that it doesn't get out of control. And so I just had a question from Abel. It says, I'm not sure if I missed this. Can you subdivide using different methods? What do you mean by different methods? The only way you can subdivide is by if you want to subdivide the whole geometry, then it's simply subdivide command, which is D. Or if you want to add resolution to a specific portion of your geometry, then I would just go ahead to edges and add loops, basically, if that makes any sense. So you can add more resolution. These are the only two sort of subdivide ways. Hopefully that answers the question. Great. So I'm just going to go ahead and move this back. So I know now this is kind of the new addition that I wanted here a little bit. So let's say in terms of, this is just sort of design subjective things, depending on how people like to view their designs, but all I'm doing is sort of adjusting the some of the just the curvatures, that it's actually not too crazy, and just remains high res. So I think now this is kind of looking good. I like how this is. Maybe this edge needs to go up a little bit. So I'm just going to go ahead and slide it up, just so that I can maintain the integrity of the curve that I just drew. So this is now, I'm adding. So now that I have this, what I want to do is probably punch a hole through this geometry and possibly maybe even increase the resolution of it, which I will do in a second. But there is a way you can sort of use these two polygons to puncture through, let's say. So the way I'm going to do it is by going into the polygon mode and using these two polygons to sort of move in. But if I just move the move command, this is just going to deform the geometry, which is not something I want. I want it to sort of create new polygons that can create an aperture or a void within this. So the way we do that is by it's basically the bevel command that I use for the scenes. So you go to polygon and go bevel, and you see that already sort of created the ledge that I wanted to work with. I can adjust the polygons themselves so that they're not too far into the edge, and this way will give me a little bit more control. I can also control these by using the move command and the rotate and so on. For now, I think it's okay. It may be here that needs some adjustment so that the integrity of the design is not too bad, and it's sort of maintained. There's no strange edges anywhere. What I also want to make sure that once I'm done with the design, there's some instances that are like this that are sort of looks like it's not high res. And the way I'm going to do that is once I'm done with the design, I can subdivide and add more resolution to this. But for now, I want to work with low poly so that my polygon count is not too high, and things like that can easily be resolved right before the export. All right, so now that I have this ledge, I wanted to actually, let's see if we can do it. I wanted to increase the resolution of this just so that it gives me a little bit more. So I'm just selecting the two edges and increasing, so adding a crease right at the edge here. And what I'm going to do as well is move this point so that things are not too out of control. And this just helps me to always go back and sort of control the geometry as much as I can. What I'm also going to do is possibly decrease this direction, which seems to be already at its max, and maybe move this up a little bit, just so that looks like it's a bit tilted. So we can. It's all about just sort of finessing the design itself. Okay, and maybe I can do that a little bit. So now that's kind of giving me a little bit of a ledge. We can puncture something through. We can add another. We can add another bevel, certainly, and that will give us a little bit more space. And what I can do with that is push it down to start really creating the space for something to be hosted here. So now I can host plants. I can host, I can add something. Maybe I can add seeds or something that I can integrate into the wall. But it's just basically me creating a pocket within the space here. And what I can do is just by simply making it smaller to increase the resolution and so on. And now, if I look at the geometry here, it looks okay. I can increase the resolution of this towards the end so that it's not too broken. But I think it looks okay for now with a low poly. I'm just going to go ahead and make it straight. All I'm doing is increasing or decreasing the spacing of it in the direction. Okay, I'm just going to go ahead and bring in this point out this way. Okay, I think this is sort of a way to add something. I can always add a loop. But I guess that's going to mess up some things that I might have to fix. But so I'm just going to go ahead and leave it this way for now. There's also a way where we can start adding more articulation, as I was doing before. But yeah, all I'm going to do now is sort of start to work with this. So now we can sort of add more resolution to it. I can always go back and sort of add more textures. I can also manipulate sort of the sculpture aspect of things. So if I wanted the bottom of this to be, you know, more sculptural and kind of does the same thing where there's a bulge here. Of course, I can always do that by going into the left view and then take the linear fall off, draw it in a way where I want to distribute my forces from, let's say, the least amount of force it would be at that corner, the most amount of force would be on this corner, and we can sculpt that a little bit. You know, we can bring it out, we can scale it, and so on, and that will give me a little bit more sort of resolution here. You can always rotate it to add a little bit of a ledge, which I think is kind of nice. Maybe we can add a bench or something here at some point, but we can start establishing these rules as I go. So I do like this thing because now I'm thinking about how can I CNC this. I want to make sure that there are no undercuts or anything like that, so that the CNC doesn't have too much trouble getting this panel. So now this is, I think, this kind of nice sort of bulging in, out, and again, is a good, and all I'm going to do is probably, I'm just going to select all the edges here and increase the resolution of them so that I have this kind of nice finish. Okay, so I can do something else somewhere else. You know, let's say I wanted to have some kind of a shading element to this. Maybe that can go over the plant or something. Then certainly I can select these polygons here, and then go to the left view, which is the front view of this, and add a fall off in this direction. So the least amount of fall off would happen here, and the most, I actually almost don't want it to happen here. I want it to stop there. And I'm just going to go to perspective and then start sculpting this the exact same way I sculpted sort of this thing at the bottom. I'm just adjusting the scale of it. As you can see, mostly move is good so that you can move top. You can also rotate so that it kind of curves out a little bit, so create this pocket surface. What I also want to do in a second is think about the functionality of this pocket that I created. But before I do that, I just want to make sure it's not too crazy, so I'm just going to go ahead and put it back. I'm going to select the edges here, increase the resolution of it, so it also has this nice cut. Again, it's Shift W. I'm just going to do 100%. Sometimes it goes beyond 100%, but 100 is the biggest sort of force. So when I have this, then what I want to do is possibly look at how we can direct water into this. So potentially I can use these edges here to add seams, and these seams would help me sort of collect water from, if it's raining here, let's say, and I wanted to collect the water that's happening here and direct it all the way down to the pocket to collect water, for example, so we can just add seams. Before I do that, actually, I'm going to go ahead and take the crease off of the edge that I just created. I'll add the crease in a second. I want to add the seams first. So I'm just going to go ahead and say, I want to move this guy in a little bit. I also want to move this thing in here and maybe rotate it a little bit. And then I want to add this so that we have sort of 3 different venues that we can use to direct water into this. And what I want to do here is actually add another loop inside here so that I can control the thickness of this. Surface is getting a little thin. I'm just going to go ahead and make this slightly smaller. I'm doing this. All right, So I'm just going to scale this down a little bit so that that gives me a little bit more space, which is good. Okay, that fixes some of the resolution issues that we had with this pocket. Okay, so now I have these sort of three scenes that I can create. So I'm just going to go ahead and do the exact same thing what I did with the scene. So we have this one. Let's just try to create at least one here in the middle. So all I'm going to do is, this looks good. What I'm going to do is go ahead and bevel the edges here. Okay. I'm just going to go ahead and make this 5 in the middle. Okay. And then I'm going to go ahead and select this by pressing Alt-3. Okay. And the Alt-3 will give me the opportunity to, let's say, move this scene in. So now this gives me a little bit of an articulation within the wall that can then potentially collect water, and then that water would seep right in through the scene that we have here. I'm just trying to articulate the top of this a little bit better. Move it down. Okay, I think that's good. So now we have some kind of functional scene that kind of takes but for now, I think I'm just going to add one, just so that, I mean, I can add more edges so that the scene is actually cleaner. So I'm just going to go ahead and maybe increase these edges right here. Okay, that looks much better. Now we have this kind of function that can lead to that articulation. Of course, all of these can be, I mean, there's a way, for example, if I wanted to host something else in the wall, like let's say there's like an algae glass piece that I wanted to import in between the scenes. There's definitely a way you can do that, or we can do that. So I'm just going to save so we don't lose any of the work, the progress that we made up to this point. And what I really want to do, actually, I want to open up the scene that's in between, maybe try to host something here. So the way I'm going to do that is, I'm just going to go ahead and, let's say, select all of these scenes here and delete them. So now I have.
Hey, Fadhil, I'm just thinking it should take the 5 minutes break.
Oh, we could potentially, yeah. Let's take a 5-minute break and then we can come back. I was going to keep going, but if you guys need to.
Yeah, so we're back at 10 past 4 our time here, like in 5 minutes.
Absolutely. Cool. Okay. All right, so here's my screen again. Hopefully you can see it. Going back to Abel's question, before I actually go into the polygon tessellation, I just wanted to show one thing. Now that I've deleted the polygons that were in between, now we know that there are 4 different panels that started from the first panel that I started with. And the way I did that, I already did that for 3 of them, so I can show you how I did that for the one that's still open. So you see, once you delete the polygons, the surface is open, but the other ones are closed because I closed them in a little bit. So I'm just going to go ahead and close the surface so you know how to do it. Basically, again, it's another way to try to close off the surface using the edges. So if you press number 2, you double click on the edges of the polygons that are open. And then all I need to do, I know for a fact that all I need to do is fill the space in between that's open with polygons. So I need to bridge basically the edges that are in between, but you can't bridge things that are already connected. So we have to make sure that our selection has gaps. So what I'm going to do is deselect 4 of the edges that are in between. So there are 4 edges here that I deselected. And at the other end of this box also has 4 edges that I can deselect. 1, 2, 3, 4. So now you see the number of the edges that I've selected here is 40. It always has to be an even number. If it's an odd number, then the bridges won't be successful. So now that I have 2 sets of edges that are not connected, I can go to edges and go to bridge, hit, click on the screen, and that will create the bridge in between. And now we know that we have this is separated, this is separated. And what's nice about these pieces is that the seam in between added enough tolerance, at least 5 to 10 mil tolerance between these two, in case there is sort of fabrication, difficulty or assembling. So I'm going to go ahead and actually change the tessellation of these polygons based on a question in a little bit, or just right now. So what I'm going to do is, in order to change the tessellation of something, it has to be on a new mesh by itself. So before that, I'm just going to go ahead and save incremental so that I can preserve the previous version that I was working with. And I can double click on this. I'm just going to Control C, which is copy, and delete it because I'm going to copy it onto a different layer. I'm going to press N to add a new mesh, which is mesh number 2. And we're just going to call it, if we're looking at this here, we're going to call it bottom left corner. So now we know this is on the left. If you do Control V, that will give us, bring back the component that I just copied exactly back in place. So I can turn off everything else for now. I'll bring it back. So this is the piece that I've created based on the wall that I started with. And I'm going to go ahead and change the tessellation of that. You know, if I'm kind of limited by the tessellation of the cubes or the squares here or the rectangles, I can change that into a different configuration. And the way I do that is first you have to select all the edges. So if you go to press number 2, that takes you to edges mode and select everything, all the edges. So that's middle mouse button, select everything. And then go to Alt 3. And that will take you to the polygon mode. So now basically you have both edges of polygon selected. Then I go to polygon, and there is different kinds of arrangement, but I'm just going to go ahead and do spiky, just so that we can change the tessellation. But now it's not fully there yet. I basically turned the tessellation into you know, this kite-looking thing. So I'm just going to go ahead and go to number 2 since I have my other edges selected already, and then just delete those. And now the tessellation of this, in comparison to the rest of the meshes, is completely different. It's the same number of polygons. With the spiky, it increases it by a little bit. And I can actually, you know, play around with it and change it. Add a different articulation. Now, obviously, all the seams that I'm going to add will have a different kind of, you know, for example, if I wanted to add a seam here, and, you know, if I just wanted to add it to this face, then obviously the articulation of that will be very, very different. I'm just going to go ahead and add this seam here. You can see that it's very different. So, so what I'm going to do, I can leave this. I just backed out of it because that was just an example. What I was going to actually show you is that I wanted to add sort of a spacing in between to host something. But before that, I actually just wanted to go back and bring back my piece with the exact same tessellation that I was working with, so that it's not different yet. I don't want to change the tessellation just yet. I was just sort of to show you how to change that. And I want to use this piece. I like this curve here. And if I want to push this curve out a little bit, this way, I can create a spacing for something to be hosted there, like a glass, let's say a glass vessel that can sit inside and host some algae or something in a sort of very scientific way. So what I'm going to do is select just the polygons here, use the seam that's already in place. And again, all of these objects now are separated, So they're all ready to be 3D printed or CNC. So I'm just going to go ahead and select this since I've moved it into a different mesh. And I'm just going to select these polygons real quick and push them out. But the way I want to do that is a very sort of parametric way. So I want to make sure that the least amount of force is applied on this side and the most amount of force is applied on the middle side. So again, I'm going to go to the left side and then add a linear fall off, a very small one. So most force is here, least amount of force is there, let's say, and then I'm just going to go ahead and use the move tool, and that will just open up a little bit of space. What I also want to do is I want to deselect this. So now that we have a little bit of space, and then I'm just going to go ahead and do that. Just push my polygons out a little bit. So now there's a space or opening for something to be hosted inside. I want to make sure that my edges or my surface is not ruined. I think we might need to push this in a little bit, And now we have this opening here. So what I'm going to do now is that there's a space that we can create a different object inside. So I'm just going to go ahead and let's say select these two. What is it? How many? Is it 6 objects? So I'm just going to do the same thing. Well, actually, let me just do one thing real quick. I'm just going to go ahead and bring this component into the next layer. I'm just copying and pasting so that I can access both of them. Because if I'm in a different layer, I can access the ones that are on a different mesh. So I'm just going to go ahead and select these 6 polygons. So now we have this kind of, I'm just going to copy them. And then I'm going to paste them in place, move them out. Let's say by, that's fine, 500, or let's say 1 meter, just so that they're out. I can work with them a little bit. And what I'm going to do is I want to, so you can see the inside of it, but you can't see the outside because the polygons are flipped. So if you can double click on both of them, hit F, so you can flip them now and you can see the outside of it. And then you can select the outer edges. You have 20, that means it's 10, 10 on each side. And then I'm just going to go ahead and go to edges, bridge. And now we have this kind of object in between. What I'm going to do to this object to scale it down by a little bit, maybe by 5%. So I'm just going to go ahead and scale it. I will make it hit the equal button here. Just put 95, so now it's in all directions. And then I'm just going to go ahead and move it back. I think I moved it by 1. And now we have this thing that can host something else. I'm just going to apply a different material to it. Green. I'm applying material by pressing M, and that's going to add material to the object that I'm selecting. So now that this is green, we can select this green, for example, and that should make my object green. So now we have something that we can, let's say an object that we can 3D print. It could be glass, it could be something else, that we can then host something inside and put it inside the wall. If you want to test material or test, as it's sort of a gradual process. If we're printing this out of stone, for example, but I have some kind of a biomaterial that I'm not sure how it's actually going to react to the environment. Instead of having to build a whole thing, maybe we can create that material, 3D print that biomaterial, and sort of integrate it as part of the architectural panel. So now, in a sense, that you have a sort of we started with a box, and you have 4 different panels that are doing very different things. So this panel, for example, is strictly sort of doing panel work. This panel here has kind of a shading device with a water system and a kind of a planting. These 2 have different articulation systems, and then with something hosted here. Of course, there's always a way to add to this panel, but I'm just gonna need to make sure I'm sort of aware of the time of the workshop. So I wanted to touch upon some of the rendering things, some of the rendering techniques, and then I'll show you. Maybe we can have 15 minutes towards the end for questions. But before I move into rendering, I'm just going to go ahead and save this incrementally. And what I'm sort of happy about in terms of this process is that we started with a very simple geometry. It was just a box, and now we divided into multiple components. These components are sort of small scale. Again, we started by 2 by 1, still is 2 by 1. We never left the sort of the grid that I've set up for myself. And this is kind of ready to go. I mean, it could be integrated. It could be brought into a BIM system, or it could be brought into a different sort of software. It could be a standalone piece by itself. It could be like a furniture or like an urban furniture piece. But I do notice that Abel has a question.
Yeah, quick question. Can you save this as a FBX or even dare to say an IFC?
So we can export the file, and you can see all the compatible files that are here.
So you have collided to have FBX.
Yes, you can always
OBJ.
STL, there's OBJ.
Oh, so you can, if you like, you can put this in a Revit family. Yeah, no worries.
You should be able to.
Oh, you can. You have Autodesk FBX 2018.
Yep.
And that should do the trick. Perfect.
I mean, even STL, we'll bring it. I mean, there's always but yeah, you can definitely bring it as a point object, and you can always bring it as a mass to sort of tell the Revit that it's a wall, and then go from there.
Put a category, put in a template, and add a category. Oh, that's excellent. Okay, cool.
So
thank you.
Yeah, so that's the export. It's simply, as I was saying, just in case I did it fast, it's file export, and that's how you export the object. One thing before you export this object, so that you don't lose the quality of it, because if you go to Rhino sub D, you can certainly export it the way it is. If you're going to Rhino NURBS surface, then the resolution of it might be lost. So you might just have to sort of subdivide it a couple of minutes or a little bit more, so that you have more polygons, so you don't lose the resolution of it. And what I did is I just pressed D twice, so that we increase the level of it. So this is the component here that's made out of multiple components. And of course, there's always a way you can move beyond as you probably all can predict, you can move beyond the wall that you've set up for yourself, and you can sculpt this new piece and so on and so forth and increase. And that's what I like the most. I mean, as much as that, I think all the BIM systems that are really spectacular in terms of bringing different objects together, we do lose some of this sort of free form, fluidity, organic, sort of model making or digital sculpting. But then if we start sort of thinking about design in that kind of way, and as we're designing, sort of, I'm already thinking about 3D printing. I'm already thinking about CNCing. I'm thinking about how I can transport this. 2 by 1 piece of, let's say, stone is very difficult to transport, but a 1 by 1 is a much easier one. So it's already kind of divided, so that procurement aspect of things is not too difficult. And again, before I move into the rendering aspect of this, which is it's going to be a very, hopefully simpler one, because it's a very simple rendering system. I wanted to highlight that these parts are already ready to go to be imported into software or be exported to be 3D printed or CNC'd. So that's here. I think I've already saved, but I'm just saving one more time. Of course, there's, as I was saying before, there is a way you can sort of, maybe I can do it in a different workshop where I can go into the schematic, design schematic window here. And this is a place where we can, maybe I can show a quick example of what happens. But this is a way for us to start working in nodes. For example, if I wanted to, bring in new geometries that are preset here. And I'm not going to go into it because it might take a minute, but we can always automate this, and we can add different forces and particles and different deformers and different forces and fall-offs. And that would, instead of me doing it manually, we can always do it through a procedural way through this window as things sort of evolve here. But I just wanted this workshop just to show the sort of the technique of a design in a manual way, just to get the point across, and the automation or the procedural aspect of it is slightly straightforward technique. So now I'm just going to go ahead and go to Render tab here, and I'm going to make sure that my computer can handle this. Hopefully it can. And it's a pretty simple, it's a built-in rendering system, real-time rendering system, and in Modo. As you can see, the top left screen is where you get to see your camera. All the camera settings are here. You can always switch cameras if you've added multiple ones. And then you have the rendering tab and the properties on the bottom of this. And that's when you get to control sort of frames and pixels and sort of the resolution of your output. And then on this tab, you have different ways you can look at a camera where we work. This is sort of where this is sort of the view and the window we were working in. And then you have the gradient editor, and you have the preset browser where you can actually import material from different parts. The material library is really rich. Foundry is, I mean, of course, you can import your own shaders as long as it's compatible with the shader system within Modo, but Modo itself has a lot of a really good library. And you can, back in the days before they established their cloud, it was all built into the software, but now everything is in the cloud. So there's a cloud asset, and all the assets are here. You have environments, which are basically different studio lighting systems that you can set up for your scene. You have indoor, you have outdoor. Of course, you can create your own using different lights. And then that's within the environment. You have images of textures that you can bring in and add if you like. We're waiting for it to load here. It's a little bit slow. And then you have profiles. You have, within the profiles, you can, of course, bring in, miscellaneous with different shapes that are already in there. As you were saying, I was saying, like different shapes that has, these are just curves you can start with. I'm never really here because I know exactly what I want going into it. You have different meshes. If you wanted to bring in, a character, you have different humans or different, strange characters in some instances. I mean, I don't know what happened. Maybe there's a human category somewhere. Oh, there it is. Okay. You have scale figures that you can bring into your design just for the sake of scale. And then the most important one, which is materials. As I was saying, it has a decent library. Starts with fabrics and furs, glass, lights, metals, all different kinds of organic. Of course, you have the concretes and the stone aspect of things. And the way you apply material is by simply double clicking on it. So I'm just going to go ahead and use a simple material so it's not too heavy on the computer to compute. I just wanted to paint it material, and I'm just going to use this preset material. Just go okay, and it's right here. And the base shader is already that, which is basically the shader that I set for my geometry. And I'm just going to go ahead and make sure that the render frames or pixels is not too crazy. I mean, I think this is fine. This is relatively low resolution. I'm just going to go ahead and save incremental, and then I'm just going to go ahead and hit render. And that's where the render is. And it's a real-time render. So now you can see all the seams and all the different articulation that I've added into the system. What's really interesting is that if you go to model, and let's say I wanted to have this view to be rendered. So I'm just going to go ahead and set the view. Then you go to camera, and then you can hit sync to view, which means that this view will immediately become your camera view for render. So I'm just going to hit sync to view. And I think the focal length is a bit too much, so I'm just going to go ahead and lower that to 35. And now when I go to render, and I'm going to save this, I can click that, and then that's going to give me, of course, I can change the focal length of the camera and all that stuff, as I was saying earlier here. But I think 35 is fine. And if you're not satisfied with it, you can use the handle up top to adjust the rotation and the move. And I think that's okay for now. Of course, once you're ready, you go ahead and hit render, and it will render the panel for you. And of course, I can go into more of the material shaders and all that stuff. I think this stuff is pretty straightforward. What I was going to say is I've added a green material, which is this one. It's still the color that I've added to it. So I just want to add a different material to the green to make sure it's all good. So I'm just going to go to the cloud assets, go to the materials, and go to painted. Possibly find something also green that's not too shiny, and then select it to, this is your downloading from the cloud, and then there it is, it's within that, and it should be the same color green, but that is basically that object inside, just so that we can see it. But yeah, that's sort of an overview of Modo. I know we have less than 30 minutes left. That's just sort of an overview of how the camera angles work, how to sort of sync views, how to render, how to apply material. And there's, of course, you can go back and adjust all different kinds of rendering settings. And even in the green material that I just added, everything has a different, you can adjust the opacities and the transparency of things and all these things that you can get into, that I can go into in more depth in a different workshop for rendering specifically. But this is a pretty straightforward, I would say, rendering settings that you can see in all different kinds of softwares that you can adjust material settings and render settings. And I think most of the terminology here is familiar to anyone who's been in design or architecture or school or has rendered before. So I think that's it from my side. I can keep going with sculpting this and improving it, but I was going to open it up for you guys to ask any questions if you think this methodology. But I just wanted to close out with the question of instead of having to think of buildings as walls and roofs in a BIM system, we can certainly start thinking about it as components. We can create components in softwares that are like Modo or maybe Rhino, but in this case Modo, and sort of bring it in as components, start integrating more sort of intuitive ways of the design, and thinking about you can bring that into the BIM system, but at the same time you're also ready to take that component into the fabrication system. So you really are constantly having, there's always going to be a version of this design sitting in the original software where you designed it. There's always going to be a version of this design that's sitting in the BIM sort of virtual twin that also exists. And there's a physical aspect of this once the fabrication system starts. So I'm going to open it up for any questions. And if you want to discuss that, or if there's any way we can have sort of BIM systems to start facilitating the transition from, a software like this into a bit more construction-based, realistic sort of design or documentation software like Revit. So if you guys are ready, I'm happy to answer any questions.
Hi there. So the desk, you know, if you want to put your cameras on, you can.
Yeah.
I believe. So I have a question to start with.
Sure.
Can you push and pull surfaces with other surfaces? So can you create another object and just push it and use that to distort, as if you pressing a hard object against clay, for example?
Right, yes. So that would be within the animation world. And then you can always, I mean, I was just saying in the tab here, there's within the schematic or the procedural aspect of things, there's always ways you can add deformers, you can add particles, you can add volumes, and you can, of course, go into the world of collisions and hard surfaces, soft surfaces, and you can start now animating that onto the surface. But that's a completely different kind of world that I can
you have like a procedural modeling there down there.
Yeah, as I was saying, so I did introduce this technique as a manual way just so that I get the point across. But we can certainly, I mean, as I was saying, the tab where you are is here. And this I use this procedure as you know, a way to do schematic design when I use booleans. So I can move objects against something else and it will do it sort of, I can actually maybe show you something here real quick. It's mostly a Boolean operation. So if I can turn off these two objects that I created, I'm just going to create two separate objects. So let's say I have brought in these two things, and I'm just going to go ahead and select it all, move it, and rotate it. And then I'm just going to make it smaller. And let's just say we want to move this object against this. So it's going to be a Boolean operation, so schematic design. So what I'm going to do is go to 5, select both of them, and go ahead and do a new fusion. And now both of these objects are actually.
That's interesting. So you do have that. That's for visual programming, yeah?
Yeah. That creates sort of the components. So these are the two geometries. It's creating an intersection, and then it's unioning the two things. And what's really interesting about this is that now, if you go into the actual piece and then you move it, that's a real real-time
updates.
Yeah. And so on. I mean, you can definitely add.
Can you do like a cut? Can you subtract?
Yep, I was about to do that. Yeah. So basically, if you go to the schematic design, it's Control F, or sorry, Control here, and go into perspective, and then I'm just going to go ahead and hit Control F. And go to subtract. And then I'm just going to bring in my two geometries that I've started with, right? So A through and B. And then that should subtract, right? If I add that correctly to here, that's a subtract this.
And then if you move it, it will move as before, yeah?
Exactly. Yeah, exactly that.
Okay, so it's that.
Yeah. And you know, of course, as I was saying, you know, you can add more particles and volumes, and the follow-up that I was working with as well as a procedural way. I definitely need to. I'm sort of in the way of trying to, or in the process of trying to transition into more of a procedural, similar system, but more procedural, so that I can automate it, create variations very quickly, etc. But this is sort of a tease of how schematic and procedural modeling can actually, you know, again, I do like Modo quite a bit because, you know, you have the world here is, you know, you even have like topological modeling where you can actually sculpt, like, you know, in a different software where you're not dealing with polygons anymore, but you're actually sculpting the actual geometry dealing. So you're moving between polygons and sculpting and booleans and schematic design, and it's, you know, the transition is it's pretty fluid, I would say. So
cool.
Yeah.
So Gokhan and Michelle, any questions? No questions. I will ask another question then.
Okay. Please.
I've used lots of different 3D modeling software, things like Maya, 3D Max, and
Yep.
Blender, and all that. And so the functionalities you did show today, they are in all different softwares I've been using. However, we can obviously see that it's just very fluid and easy to use in Modo. Yeah, it's just like, it's almost like it's digital sculpting, and seems to be very intuitive. So it's just, if you can talk a little bit about the reasons why you picked this tool and not something else, and if the software itself changed your workflow and how you make things.
Yeah. So the reason why I picked this, I mean, I did test a little bit of 3ds Max and Maya, but I mean, the first time I was introduced to this tool was at the beginning of my graduate time, when I was in grad school at the Bartlett. At Unit 20 with Javier Ruiz and Marian Coletti and Marcus Cruz. At the time, they were working specifically with Modo, and I had no idea what Modo was at the time. I was familiar with surface modeling, but I haven't really gotten into it. So that was my first introduction to it. But as soon as I started using the tool, I was mostly in Rhino, and maybe doing some Grasshopper on the side. But when I immediately realized that I have a lot of control over this, and if I can establish a technique that I can then maybe automate it at some point, but a technique that can help me, because mostly I sort of know what I want right off the bat. So, but what's nice about Modo is that you can really achieve what you want, but there are also other tools that we can experiment with and run into some like accidental or experimental things as you go. So I did like the fact that it's intuitive in one hand, but also, on one, you can do what you want, but at the same time run into or do experimental things. So that's number one. The fact that I'm able to sculpt and use surface modeling and also schematic fusion, which is this tool that I just started, and that fluidity in the process just helps me integrate things a lot more. So, and especially if I'm working with components, then I can certainly say now computational design is at its like finest, where one of the components could be designed schematically, and another one is if you can't achieve it schematically and you really want to go with an intuitive, strange looking thing, and you want to really control every single point of it, then you can certainly do that within the same model. So
yeah, it's
really,
true, isn't it? You did a Boolean transaction there, and it created the visual scripting description of that, right?
Yeah. So it's really nice to move between these things. I mean, I was, again, with the previous models that I've created, if we go back to them, these models are, I'm just going to close out of this real quick. And, these models can always, I can always bring in another thing and Boolean difference it within something that I've already established, right? An object that already exists, or something that I sculpt separately, but I wanted to have a specific positioning, then the Boolean operation or the fusion can work really well with this. And I can also take one of the components if I'm sort of interested in changing the shape of it completely, whether it's this one or that one or any of the other two, and go to sculpting and really just specifically do whatever I want while maintaining the seam. As long as the seam is maintained, you can basically do whatever you want using the different venues or the different sections within them. So.
Did you ever try to 3D print and CNC mill objects from that? You probably did when you were in Marco's unit.
Yeah, certainly. I mean, my final project was all 3D printed out of multiple pieces. My final project was basically 80 pieces that I only printed. I transitioned from Modo into 3D printing. I had zero interaction with any kind of plan or section drawings or interaction with Rhino or any other software. I basically used that exactly what you see here, and I had a bigger project which was more of a living housing cell, and I 3D printed everything there. was 80 different components that I actually presented in the conference last year. So it's in the video from last year's presentation for those who are interested in seeing that process more of in a presentation format. And yeah, all these things were printed, and literally the movement was from Modo into 3D printing.
Okay, so that's very direct, and it's a very direct relationship, very different from other processes. Well, processes that we still need to have for very large projects, very large
projects. Yeah, exactly. I agree. That's why I said at the beginning, I'm sort of still working on very small scale products to small scale kind of housing projects with this method. I'm not sure scaling up how, I mean, there are a lot of challenges if we were to scale up just because of the size of things, the coordination of different aspects. And you guys were talking about that earlier with the infrastructural projects, but yeah.
Yeah, in our ideal world, we would like to be able to not have to rely on drawings and all that. You know, we can bypass that now with, you know, augmented reality, and VR, and all that. And also, you know, effective, you know, really, you know, robust, accommodate environments where you can share everything. So I just wonder, is Modo working with things like the Omniverse, you know, the NVIDIA Omniverse? So NVIDIA has, yeah, the Omniverse is this virtual environment where you can put your objects,
right,
and you can design and 3D model them in whatever software you want. And you can federate all of them in this one accommodate environment called the Omniverse. So it works, yeah, like omni, like in Latin, like all universes, yeah.
Right.
And the idea is that you federate, you know, use whatever tool you want. You have the Omniverse plugin, the NVIDIA Omniverse plugin, and
right.
And then you just bring everything together, a little bit like a BIM 360 or Construction Cloud.
Okay.
Bring everything in one place. But it doesn't do other things as far as I understand it. It doesn't do, for example, clash detection and other things we need when we're building things. It's very effective for bringing a scene for a game, for example, a scene for a film, if you like an environment designer for a film or a game. So that seems to be amazing. And you can run physics in real time. So let's say you have your objects, one of them is a car, and the car will drive through whatever path you have, and it will crash and deform and so on. So it can run some physics. So I think some software are working with the Omniverse. Some even game engines are working with the Omniverse, like Unreal Engine. Unity is on its way to work with the Omniverse, but you can use this to federate everything. And hopefully, if it really works and if it becomes very intuitive, then you wouldn't need drawings or or anything like that.
Yeah.
And then people just pick the tools they like most, the tools that feel intuitive and natural for them to create forms and to sculpt or to specify, and then they would use that. And I think you can also, not sure yet, but I think, let's say you model something in Modo, and then somebody is using the Omniverse with you, and then they can pick your model to run a structure analysis and then put it back.
Yeah. Okay.
So it becomes like almost.
What I was going to say, like, what is it really interesting? We can definitely take that component into Grasshopper, and then we can transfer it and analyze it and see its environmental impact and its structural impact and all that stuff. So we do have it is compatible with other plugins. It's just that the workflow is slightly more intuitive when it comes to the design aspect of things. So
cool. Yeah, so it's very interesting. Are you using any other tools at the moment to 3D model, or
so Rhino definitely. I mean, what I'm introducing now is, Rhino has recently started the sub-D version of Rhino, which is very similar. I mean, it's not quite there yet. I think it's the first time they introduced sub-D for Rhino 7. I'm sure the tool will get better with time. So I'm trying to see if I can use the sub-D transition to see if I can integrate Grasshopper into this and start to manipulate the forms in a way that slightly more procedural. So that's one way. So it's between Rhino, Grasshopper, and this. I did use Houdini slightly with this. So I would take one of the components, and if I wanted to perforate it or change the textures of it in a more procedural way, if I don't care about texture too much and I just wanted to add a specific texture to it, it's just a matter of exporting one component into, as long as you keep it in the same place, you go to Houdini, script it, and as long as you maintain the theme that you've already bounded yourself with, then you can change and deform whatever you want and bring the Houdini model back into Modo and render it. Or you can 3D print that and sort of integrate it with the actual 3D print. So I've done a lot of branching to Houdini and Rhino for sure.
Okay, yeah, because Houdini is also pretty cool. It's an amazing piece of software.
Yeah.
I believe the CT, the procedural CT in the Matrix demo, like Unreal Engine Matrix demo, was all done scripted in Houdini, right?
I think so. I mean, I'm not too sure personally.
Yeah, I think I've seen a talk about it. The guys who developed the CT showing it how it was done in Houdini. So it's very nice. It's very cool to see how some tools are just becoming very intuitive, and that's where we want to go. There was a time that you tried to 3D model something, and it was an absolute nightmare, even if it was very simple. I remember at uni many years ago, I used a software called Wavefront. Which was supposed to be good, but it was an absolute nightmare to use. So difficult. To just make a simple double curve surface.
Yeah, times have changed certainly. I am a big fan of hybridization. So if there's any opportunity where Modo lacks sort of any sort of technique I want to implement in Modo is either it takes too long if I want to do it manually or whatever, then I can easily branch out into Houdini, do that specific thing, and come back into the same scene. Or we can branch out, go to Houdini, as long as in the physical world, you come back and you assemble it in a way that still connects.
Yeah. That sounds like a very nice process. It would be great to see it, this interoperability between Houdini and Modo, and how you call Houdini and Grasshopper and Rhino. Yeah. And how that works for you. Yeah, that's interesting. Really cool.
Cool.
I don't know if people have more questions, but if they don't, so we can, I think we reach our time, right? And